And welcome to another video. This is going to be video number 2 or lesson 2 on linear review. So in the previous video, we were looking at y is equal to mx plus c, gradient form, coordinates, all the good stuff, and special lines. So if you haven't seen that already, I'd probably recommend watching that unless you've got a good foundation. In this video, we're going to be looking at sketching linear equations, but also finding the equation of a line from a graph. So the first thing, we're going to learn 2 strategies for sketching. The first one's going to be using y is equal to mx plus c form. Then we're going to be sketching using the x and the y intercepts. So here we go. We may remember y is equal to mx plus c, where m is the gradient, and I'll try a different color there. M is the gradient, and c is the y-intercept. Okay, so let's just firstly interpret these equations. These are all linear because they hold the form y is equal to mx plus c. So in this first one, we've got m, which is always in front of the x, is 3 on 2. So let's write that down. That's our gradient. So gradient, there's m. And what does this mean? It means it's going to go rise over run, so rise 3 and then across 2. And what I'm going to do, I'm just going to move that bit there and maybe put it here. Gradient and the arrow to the m. So rise over run. So rise is 3, run is 2. So it's going across 2 and then it's going up 3. Cross 2, up 3. Cross 2, up 3. The y-intercept in this case is going to be -2, not just 2, but -2. Okay, so let's write that down. -2. That means it cuts the y-axis at -2, which means it goes down 2. So with that, let's sketch this line. Okay, first step when sketching lines is we start at the y-intercept. Okay, now in this case, they're starting at the y-intercept of -2. So let's draw a big dot there at -2. There we go. So that's our y-intercept there. Now, the gradient saying go across 2, up 3, cross 2, up 3. So we can go across 2 and then we can go up 3. Now, what we do is you put a dot at the next point. Cross 2, up 3. Draw another dot. Now we can see here we've run out of space. And if I try to retrace my steps, I can see it's going to be pretty hard to sketch that next one because it goes off the grid. So now what we can do is we can sketch a line like this. And obviously yours is going to be a little bit better than mine. And then we draw arrows at the end to say that this line does continue past the grid. Okay, so the grid is just showing where the line exists. But when it goes off the grid, the arrows show this line is going to continue forever, both ways. Now, you can label this A. The reason we're going to label is because there's going to be a lot of graphs drawn here. It's going to be pretty hard to tell what's what. Let's do the next one. So we've got our gradient of -3 and a y-intercept of +3. So gradient is -1 on 3 and the y-intercept is +3. So this is going to go rise over run, and it's a negative gradient, which means downhill. Therefore it's going cross 3, but then it's going down 1. Cross 3, down 1. Cross 3, down 1. So the slope's not going to be that steep. The y-intercept, it cuts the axis at 3, +3. Let's draw this in. First step, start the y-intercept. Oh, I was meant to finish this. Then use the gradient. And then draw a line. Preferably with a ruler. So here we go. We're at 3 now, and it's going across 3, down 1. Cross 3, down 1. So cross 3, 1, 2, 3, down 1. There we go. Now, you may see a problem here is that we're going to run out of space if we go at this again. You can see out here we've run out of grid space. Now, what we can do is backtrack. So this can go cross 3, but to balance it out, we need to go up 1. Draw a dot there. Now, that's probably enough for us. So what we're going to do is simply just try to draw a line as best we can through this, like that. And then I'm going to label this one B, equation B. Let's move on. C, our gradient is 2, y-intercept's -1. Draw a dot at -1. Now the gradient of 2, if you've just got a number floating there, always write it as 2 over 1. okay? 2 over 1. The reason we do that is we can get our story straight. It's going cross 1 and then it's going up 2. Cross 1, up 2. Cross 1, up 2. If you don't write that 1, it gets a bit hard to know what the gradient was. Okay, so it's going cross 1, up 2. Cross 1, up 2. Okay, and then we can go backwards. Cross 1, down 2. There we go. We should have enough here. And let's call that C. The last one, and let's go blue, -½ and the y-intercept is something. Now, if I put a +0 there, we know that a +0, in normal maths, a +0, we just don't include it. +0 doesn't really mean much, but it makes a lot of sense here because it shows us that there actually is a y-intercept, but the y-intercept is at 0, okay? So we're going to write 0 there. So it cuts through the y-intercept at the, and if you remember that word, the origin, okay, that's the 0, 0, and then it's going to go, a pattern, it's going to go cross 2, and as it's negative, it's going down 1, cross 2, down 1, cross 2, down 1. So cross 2, down 1, cross 2, down 1. Same the other way, cross 2, up 1, cross 2, up 1. And let's draw a line through them. Okay, and let's label that one there is D. All right, so we've got theirs, we've got all our graphs. So we've sketched there using y is equal to mx plus c form. What we're going to do next is look at sketching graphs with intercepts. Okay, now to sketch a line where the x and y's are on the same side of the equal sign. So if you've got an equation that looks like this, it's usually indicative that we should use the x and y intercepts. Questions normally tell you to plot them using this. So how do we find x and y intercepts? Well, here we go. To find an x-intercept, we know that y is equal to 0, and to find a y-intercept, we know x is equal to 0. Okay, and this will become clear in a bit, but if you think about our previous example up here, we've already talked about the y-intercepts, x is equal to 0. For the x-intercepts, we know that y must be 0. So this one here is 1, 0. See how the y is 0? And this one over here is -4, 0. Do you see how that y is 0 again? Next step is we plug in 1. So x-intercept, y is equal to 0. And y-intercept, x is equal to 0. 2, I'm going to use the word substitute in and solve. So here we go. Y, just there, is going to be replaced with a 0. So here we go. 3x take 4 times 0 is equal to 12. Then we notice that that bit cancels. So x must be 4. Now we have our coordinate. When x is 4, y is 0. Okay, we've got our first coordinate, and this is our x-intercept. For the y-intercept, we've got the same thing, but in this case, x is equal to 0. So here we go. Substitute in. Y is equal to -3. So when x is 0, y is -3. Now, this here is our y-intercept. Let's plug him in. X is 0, y is -3. Do we see how that's our y-intercept? Matches up well. And our x-intercept is at 4, 0. And you see here that's our x-intercept. Now we've got our x-intercept, y-intercept. What we do is we draw a line. Oh, I might want to say plot x and y intercepts. Then 4, draw a line. Okay, so let's draw the line there. So, not the best graph in the world, but there we have it. We've just drawn the line. 3x take 4y is equal to 12. Okay, now what we're going to have a look at, we've done sketching, we're going to have a look at trying to find the equation from a graph. Okay, so here we go. We've got 4 equations here. Now, we're always going to be using this rule. Y is equal to mx plus c, where m's the gradient and c is the y-intercept. So let's have a go at A and follow it along. We can see that it goes through the y-intercept at 0. So y is equal to something x plus something. That's going to be a 0. And let's have a look at the gradient. We're going to find another key point on the graph. So we need to get 2 dot points that definitely go through the grid. It's going cross 1 and then down 2. Cross 1, down 2. So this is going to be 2 over 1, and it's going to be negative, right? Because it's a negative gradient. Let's rewrite our equation. Y is equal to negative 2x. There's no plus 0 because we just get rid of it. There we go, that's equation A. Let's have a go at equation B. First thing, find the y-intercept. So the y-intercept in this case is 2. So we put a 2 here, it's positive 2. And then let's find the gradient. Oh, here's another point. Cross 1, up 1, cross 1, up 1. So 1 over 1. Now we can simplify this to y is equal to 1x, or just simply x plus 2. Now the next one we're going to have a look at is C. So let's get a lighter blue here. So C goes through negative 2. Okay, so something x plus something, I replace that with a negative 2. And let's look at the gradient. Find 2 points here and here. It's going across 2, and then it's going up 3. Cross 2, up 3. Cross 2, up 3, and it's positive. So it's going to be the rise is 3 and the run is 2. Let's clean this up. We don't write plus negative, we just go take 2. Last equation is D. Now D goes through a y-intercept of negative 1, and we can see that the gradient here is point to point. It's going cross 3 and then down 2. Cross 3, down 2. Cross 3, down 2. So therefore, it's going to be 2 over 3, cross 3, down 2, and it's negative because it's a negative gradient. So there we have it, we've got all our equations. Hopefully this video was useful. We looked at sketching graphs, both by using y is equal to mx plus c form, but also sketching graphs using an x-intercept and a y-intercept, and by finding those. And we also found the graph using y is equal to mx plus c form. Hopefully you found this useful, and I'm just going to clean up this final equation before I go. There we go. In the next video, we'll be looking at some modeling and does the point lie on the line. Thanks.